Good morning, students. Am I audible? Inform your friend to join as soon as possible. Okay, my audio is correct or not? Am I audible or not? Please to verify. Is it audible? Okay, so let's start. So, so recording is already started. So let me start it officially. So, good morning, all of you. This is a class of Professional Elective 1, 6th semester, and it is Railway Engineering. Clear? Uh, so overall, we have completed the fourth module. Okay, so we're going to enter in the fifth and the last module, that is your signaling, basically. Okay, signaling and interlocking. Okay, so before starting the fifth module, it means before discussing about signaling in railway engineering, I want to show you one a video related to the last module, that is your uh, fourth module. Basically, that particular video is all about your point and crossing. That means how a particular train can change a track. You will understand by seeing this video. Even in that particular video, you will see some animation, also some real picture or real field, uh, you know, picture, so that you can visualize actually how it look like in real life. Fine. Before going playing that particular video, I also mentioned you that but that particular video is prepared by a person for a different country. Some specification may not be similar with our railway engineering. Okay, like types of crossing, type of turnout. Some words may be different, but overall the basic concept of point and crossing, or you can say turnout or a track junction, is similar. That's why I have chosen that particular video to show you. Okay, so let me now share my screen and I will show you the video. Fine. Okay. Is it visible? My screen is visible or not? Okay. Chalo. So let's watch the video. So basically switch and crossing. Basically, point is also sometimes known as switches. So sometimes you can also say point and crossing, or you can also say switch and crossing. Okay, so they are similar. Clear? So now I'm going to mute myself, and video will run up to 7 minutes. Okay. If there is there any problem in audio or anything, then you can text me. Okay. I'll stop the video and I'll again let me I'll try to make it correct. Okay. चलो ठीक है. So yeah, I will now play the video.
Switches and crossings play an essential role in connecting the rail network. We use them to guide trains from one track to another and to enable lines to cross paths. Put simply, they're the junctions that allow us to create a multi-lined, multi-routed rail network. At Network Rail, we own over 20,000 switch and crossing units. They come in many different shapes and sizes, and all are made to measure for their specific location. To understand how switches and crossings work, we first got to look at the wheel-rail interaction. Train wheels move along the rails guided only by the pound-coin-sized area of wheel that sits on the railhead. The wheel rim, or flange, doesn't normally touch the rail. Flanges are only a last resort to prevent the wheels becoming derailed. A switch can guide a wheel in one of two directions. A crossing creates a gap in the rail for the flange to pass through. This is a switch, also known as a point. It's the moving part of the switch and crossing layout, and is made up of two long blades which can move across to guide the train one way or another. This is the switch rail, and this is called the toe. This is called the stock rail. It's a non-moving part of the switch. The two switch blades are fixed to each other by a stretcher bar to ensure that when one is against its stock rail, the other is fully clear and will provide room for the wheel flange to pass through cleanly. This is a crossing. It's the non-moving part of the switch and crossing layout that allows a train to pass in either direction once the switch has been set. This is the nose of the crossing. Either side of the crossing area, wing and check rails are provided to assist the guidance of the wheel sets through the crossing. Crossings can be either fabricated, made up of two machined rails joined together, or they can be cast as a single unit. Modern crossings are now cast from manganese steel, which is an advanced alloy that gets harder with use. This is an important property as the nose of the crossing can take high impact loads as train wheels pass through.
My name's Lawrence Fulton and I'm a graduate engineer working for Network Rail. I'm here today to teach you about switches and crossings. The most simple form of S&C is the turnout. This is a left-hand turnout. As you can see, it diverges from the main route in a leftward direction. This is how it works. In normal mode, the left-hand wheel rolls along the switch rail. There's flangeway clearance for the right wheel to continue along the stock rail. The inside surface of the right flange is kept on course by the check rail. This restrains the wheel set and ensures this is directed along the correct route. Meanwhile, the left wheel transfers contact between the different parts of the crossing. That's where there's a high impact load. In the reverse, the right wheel rolls over the switch rail and follows its geometry. The inside surface of the left flange is guided by the check. forcing it to follow the stock rail on the new route. And the right-hand wheel makes a crossing, again impacting a load on the crossing nose.
There are many different types of switch and crossing on the network. They include turnouts, diamonds, crossovers, and slit diamonds. The type we use is determined by a number of factors, including the number of lines involved, frequency of use, and running line speed. Trains travelling at high speeds need long switches and crossings. At low speeds, such as in stations, trains can make tighter turns. Train movements across the network are set and controlled by signallers, who use switches to set routes for trains. Switches can be propelled by various devices. One of the simplest forms is the ground frame setup, a series of rods and cams attached to levers in signal boxes. These are now largely being replaced by remotely operated hydraulic and electromechanical devices.
Seen by rail sides all across the country. This is an HW2000 for its machine. This is electromechanical. What we have here is your drive motor. To check the motor has done its job, over here we have an interlocking and detection system. Detection tells us when the points have completed their travel and locked. Locking holds the points in this state so they cannot be physically moved. So when a train runs over the top, it remains in position. Facing point locks are one of the most important safety features on the S&C layout. They ensure that the points cannot be moved when set. This is important because failure to lock the switches could cause a derailment.
As engineers, we face an ongoing challenge to maintain and improve our switch and crossing assets. Trains can create large impact and lateral forces as they change course, and these forces can cause wear and deformation. Switches and crossings therefore have a limited lifespan before we need to replace them. Less than 5% of track miles are made up of switches and crossings, but over 17% of our maintenance budget is spent on them. We'll continue to research and develop new inspection techniques and material usage to increase their performance.
It's all about creating a network that's safe, reliable and efficient. It's what we do.
Am I audible? Yes, sir. Okay, did it completed the video? Because there was a current issue. Okay, just suddenly current gone. That's why maybe some internet problem may be there. So is this completed or not? Okay, I'll show you the last part of that particular video. Okay, it starts. You can show. Okay, I'll show you. Wait.
Switches and crossings, but over 17% of our maintenance budget is spent on them. We'll continue to research and develop new inspection techniques and material usage to increase their performance.
It's all about creating a network that's safe, reliable and efficient. It's what we do.
Okay, this is all about that video. I think it was clear, right? So basically, in that particular video, a properly complete explanation is given about the basic mechanism of point and crossing. Okay, that's why I have chosen this particular video. It was so clear with the animation. Fine. So with this, I just want to complete that fourth module. Okay. So with that particular video, uh, the fourth module is completed. Now we can go to the last module. That is your point. That one your that one signaling. Yeah, signaling system. Okay. So let me first share the screen again. Wait. Is it visible to you? So yeah, so let's start the basics of signaling. Okay. So in this class, we're going to discuss about the basic purpose of signaling. Fine. Then from next class, we go jump to the different types of signaling. Fine. A different type of signal that can be used in different track or different station. Okay. And but also we're going to discuss about purpose of signaling here. Fine. So let's start. So here written why and when a signaling is become very so important in day-to-day life. Okay. So in the early days of railway operation, there was seldom need for more than one train to operate on a section of track at any given time. That means with due course of time, okay, for the development of a particular society, they required numbers of track. Okay, for a particular uh, section or particular area. Okay, and with increasing in railway track, with increasing train or increasing the movement of train, the management effort is also going to be is also increases, okay, to maintain or to regulate the train movement. Okay, suppose in a particular track two train will move but at a different time, but to maintain that particular um, movement of two train over a one single track, we need a system, and that particular system also included a signaling system. Basically, signaling system basically it's to make aware the person responsible for the movement of the train. That means what is happening in particular track. Okay, so to make a particular management, or you can say uh, the person who is driving the train or who is regulating the train movement, to aware him about the um, coming situation. Anyway, so as traffic increases, it becomes necessary to operate train in both direction over single track. Okay, so I'm talking about the history when signaling started basically. So as traffic increases, it becomes necessary to operate trains both direction over a single track. The purpose of signaling and interlocking. So basically, this interlocking means um, to interlocking means the interlocking between the track. We already discussed about point and crossing, na? And the turnout, or you can say the track junction. There is an interlocking between the track. One track is branching from the another track, so it is called interlocking basically. Okay. So the purpose of signaling and interlocking is primarily to control and regulate the movement of train safely and efficiently. Okay, so it is a general purpose. The purpose of signaling and interlocking is primarily to control and regulate the movement of the train safely and efficiently. Okay, that signaling includes operation and interlocking of signal points, block instrument, and other allied equipment in a predetermined manner for a safe and efficient running of train. That means that particular overall the concept of signaling, it includes different component. Fine, component like interlocking of signals. Okay, points. We already discussed point or switches. Okay, then crossing also. Then other block instrument which are that is like switch motor or switch box. Then other different components which are very useful or very important in terms of signaling. So they are pre-decided and they are designed before running in the train. They are already designed over a railway track to regulate the train movement over a railway track. So what is the purpose basically? The purpose of signaling is to control and regulate the movement of the train safely and efficiently basically. Also, a signaling enables the movement of train to be controlled in such a way that the existing tracks are utilized to the maximum. Okay. In fact, in railway technology, signaling is a medium of communication Signaling is a medium of communication between the station master and the controller sitting in a remote place in the house and the loco pilot. Basically, the just similar to a driver which drive a vehicle. Okay, for a railway train, the person inside a locomotive is basically known as loco pilot. As per latest instruction of a railway board, as per the latest instruction of the railway board, drivers are now called loco pilot basically. So you also know these things, right? So basically, for railway, the driver of locomotive, they are known as loco pilot. Okay. So terminology, in railway terminology, the signaling is a medium of communication between the station master or the controller sitting in the remote place in the office and the loco pilot. Basically, signaling is basically it's a concept which derived or to build the communication between the loco pilot and loco pilot with the a person sitting in the control room. Okay, because from the control room, the communication or you can say the guidance to the loco pilot is given. Okay, that means which track is clear. Okay, is there any danger? These things are already given, communicated, or communication is done by this signaling. It may be done verbally over phone or by putting some signals, or you can say a signal board uh, along the railway track. I think you've also seen different kind of signaling board or signaling structure that are installed nearby the railway track. Basically, these particular signaling instruments are fixed to direct the loco pilot. Okay, so it's kind of us. The purpose is similar to the highway traffic arrangement. Okay, the purpose is same. The basic purpose is what? To sustain a safe and adequate or sufficient movement, basically. Okay. Now let's discuss about some objective of signaling. So basically, the objectives of signaling are we already discussed about that. Let's discuss in a summary. Fine. So first objective you can say to regulate the movement of train so that they run safely at maximum permissible speed. Okay. So suppose there is no provision of signaling. In that situation, there is a risk of increasing the speed of the particular train. Okay, there will be uncertainty because what's is coming in the coming track, you are uncertain. But with a signaling system, with a proper signaling system, a particular loco pilot will be um, clear in mind that up to this certain distance there is no disturbance. I can increase the speed up to certain limit. So to regulate the movement of the train so that they run safely at maximum permissible speed. So it can be done only after providing a proper signaling system across the railway track. Okay, across not across. Basically, it's along the railway track. Okay. Next, number two objective to maintain a safe distance between train. Those are running on the same line in the same direction. So of course, it is also understandable that with the signaling arrangement, we can maintain a sufficient time interval or distance between two trains or numbers of train moving along a same track. Okay, even at the same time. Okay, so a particular uh, loco driver may be informed via uh, communicating with the control room or via signal that this some distance away a particular second train is moving, so he will be aware. Okay, so like this, that means by using or by adopting signaling system we can maintain a particular safe distance between two train moving in a same track or same line in the same direction. Okay. Next, to ensure the safety of two or more trains that has to cross or approach each other. Now, when it comes to cross, we are mainly talking about crossing and point and crossing basically. So crossing of train, maybe it's done where? It's done in the turnout, or you can say in the junction, or you can say point and crossing. So in a particular section, in a point and crossing, so a particular locomotive driver, or you can say loco pilot, is to be alert that in a particular track second train is moving, so you have to change the route. So I'm giving just example. So the changing of route can be possible in the point and crossing, or you can say the railway junction, and this is only possible because of the signaling system. We have to give a direction via signaling system. Okay, so to ensure the safety of two or more trains that to cross or approach each other in a point and crossing, so basically it is a purpose of signaling. Okay, next another one, to provide facilities for safe and efficient shunting. Okay, recurring shunting we are also going to discuss, so don't worry. Okay, so to regulate the arrival and departure of the train from station yard. So even in the station yard, in a particular station are classified as different class A, class B, class C, depending on their purpose, depending on their importance, depending on the available signaling system. Okay, so there are basically four types, basically three: class A, class B, class C, and the last one, which are unblocked. It's basically classified as block class D. So class A, class B, class C are basically are known as blocked station. Okay, okay, wait. Okay, so next one, to ensure the safety of the train at level crossing when the train is required to cross the path of road vehicle. So even in the level crossing, that means usually cross the road where a railway uh, line is crossed. You can take the example of our Paniketi railway crossing, right? Nearby our downtown campus, right? That means our university campus. So this one here kind of a railway level crossing basically, huh? So level crossing basically defined as what? When a particular um, railway track crosses perpendicularly to the highway, or you can say the roadway. Okay. So in that place also, to regulate the movement of highway and railway in a same section, we need a signaling system. Okay. So whatever equipment are used for that maintaining or regulating that movement of train and as well as the vehicles moving on our route, all are included in signaling system. Okay, even when train is moving or is coming nearby the level crossing, it will signal will be given to that sub sub office which is located nearby the level crossing. Okay, fine. Anyway, so these are the basic purpose or objective you can say of signaling. Okay, next let's go to that classification of signals. Fine. So signals which are used in railway engineering can be classified based on their characteristics. Fine. So railway signals can be classified based on different characteristics which are given in the table. You can see, right? So characteristics like operational characteristics, functional, location, constructional, and spatial characteristics. Fine. So they are some subdivided subcategory of characteristics: operational characteristics, functional, location, constructional, and spatial characteristics. So different signals which are used in railway engineering, or you can say the railway signals, are classified based on characteristics. So operational means some are fixed signal basically. Okay, all are basically fixed signal. Whichever the signals are used in railway engineering, all the signboard basically you can see all are permanent. I can say fixed. So overall, based on operation, railway signals are known as fixed signal. They are fixed basically. Okay, they are based on operation. Next, based on functional characteristics, basically the purpose, you can say. What is the purpose of a particular signal? So for different signals have different purpose. Like different some example of uh, your functional signal, or you can say the signals based on functional characteristics are stop signals, permissive signals, shunt signals. Shunt signal means basically to allow a train to to cross a particular line. Okay, that means whether a second line is empty or not. Okay, to interchange the track, a signal is used, that is your shunt signal basically. Okay, anyway, so based on functional characteristics, railway signals are classified as suppose stop signal, permissive signal, shunt signal. Okay, we're going to discuss about that. For now, just try to know that term basically. Based on location. Okay, based on locational characteristics, as railway signals are classified as receptional or reception, outer, home signal, or they are known as reception signal, outer signal, home signal, departure signal. Okay, starter signal or advanced starter signal basically. Okay, based on constructional characteristics, uh, the signals railway signals are classified as semaphore signals. Okay, and its lower quadrant, upper quadrant, color light, two aspects, that is your multiple aspects, all they are basically a part of semaphore signals. Okay, this lower quadrant, upper quadrant, then color light. Okay, basically color light have a two aspect or multiple aspects. So these are basically component of this semaphore signal. Okay, we're going to discuss about semaphore signal also. Okay, so it is basically based on your constructional classification. Other special characteristics, based on special characteristics, signal railway signals are also classified as calling on signals, repeater signals, and coaching signals. Okay, so these are basically a type of signals based on characteristics. Okay, so since I already told you that all are basically a fixed signal. Okay, they are a permanent signal, you can say. So in other way also we can categorize the signals. So based on you can say here I will go for this later on. So based on another classification, the classification of signal. So overall, all are your fixed signal. So that particular fixed signal is divided under three head. Okay, it's a different kind of classification. Okay, the previous one is your classification based on your characteristics. Okay, so this is your different general classification of signal, since all our signals are fixed. So fixed is a common. So visible fixed signal can be divided under three head: your calling on signals, stop and permissible signals, and shunt signals. Okay, so these calling on signals and shunt signals are individual or unique. Okay, but the stop and permissible signals are again divided under different head. Okay, so stop and permissible signals are divided under two head. Stop and permissible signals can be colored light signal. That is maybe two, three, or four aspects maybe. Okay, so we're going to discuss about that. In other hand, the stop and permissible signals can also be categorized under semaphore signal. Okay, so we discussed right lower quadrant, modified lower quadrant, and upper quadrant. These are basically part of semaphore signal. Okay, So lower quadrant may be also known as 2 aspect, modified lower quadrant is known as a 3 aspect, and upper quadrant turns as a 3 aspect basically. So these are the part of semaphore signals. Okay. Again, semaphore signals are again categorized under different uh, category, or you can say the type of semaphore signal. As type of semaphore signals are, it can be warner signal. Okay, that means a semaphore signal can be used as a warning, giving warning. Okay, so warner signal, outer signal, home signal, starter signal, advanced starter signal, calling on shunt signal, repeater signal, good and duck signals, or are basically under semaphore signal. Okay, okay. So semaphore signals, we're going to I'll show you a picture animation, all these things. Okay, in coming classes. And colored light signals. These basically under colored light signals, some examples are distance signals, home, starter, advanced starter, repeater, automatic block. So these are also categorized under color light system. Okay. So these are basically classification of 6 signal. Okay. And these are basically classification of your based on characteristics. And if I say when in where the particular signals are used basically, so depending on the different type of station, I already told you that there are different classification of station. Okay, like class A, class B, class C. Okay, there are another one is there, class D, so we are not mentioning here. Okay, so basically they are basically categorized under their importance, okay, or the facilities and communication facility basically. Okay, so in class A railway station, the minimum requirement of signals, the basically Warner, home, and starter signals are used. So if there are available of Warner signal, home signal, and starter signal, that means you can identify this is a class A signal, a class A station. In A B class station, outer and home signals are used. In class A railway station, Warner and home signals are used. Okay, so these things are important to remember. Okay. So yeah, so this is all about today class. We have discussed basic introduction to railway signaling. Fine. So from next class, we're going to discuss more about signaling. Okay. With along with a diagram. Fine. So with this, I just want to close my sharing. And if you have any doubt, you can also ask me. Is it clear to you?
Yes, sir.
Okay. So I'll stop my video here. Oh, sorry, I'll stop my recording here. Then I'll take your attendance. Okay.